Let R be the region bounded by x equals 5, y equals 3x plus 10, y equals minus 3x plus 22. To find the volume of the solid when R is revolved around the x-axis, evaluate. You see the answers here. How do we get that? Well, you really want to, step number one, graph this stuff on the Desmos 2D grapher. And I graph this, this, and this. So I did that somewhere. Um, Right here. Yeah. So here it is. So I graphed it, did a bunch of writing, which I'll explain to you. Here's the functions. Okay, here's the line of rotation. I'll put that in there. Here's the line we're rotating about. X equals 5 right there. Okay. And here's the functions, right? Here's one of the lines going up, one line's going down. Here's x equals 5. Here's the region, this little triangle, contained between. Now, the next thing is you've got to decide, should you do discs, washers, or shells? How do you know? Because it never said. And that's the tricky point I really want to show you here. How you know is you basically, I've given you a table here. Let me show you down here. Oh, here's the picture. Yeah. Here's the CalcPlot 3D. There's what the region halfway around looks like. Yeah, that's the volume we're trying to find, that funny looking shape there, like a big frisbee with a triangle side. Here's I click down here on washers shells and it shows me you can see it's washers, not shells. So if you have time to do that, I don't know if you have time for that in an exam. Probably not on Plot 3D. So let me show you how to do it by hand, but that one is revealing it to us. Here we go. Here's a table I made on your notes. This is all notes. This is the notes, with the washer shell information. Here's the notes. It says which one to use. How do you know? Basically, it says graph the function, Desmos 2D graph we did. Draw both sideways and vertical rectangles. Correct rectangles throughout the region are required to go from one function on the top right to the other in the bottom left. They're not allowed to switch which functions they go between or go between the same function itself. So look right here. See the vertical rectangles are looking good. They go from what is it, the black function down to the blue function every time. Whereas the horizontal change their mind. See, this rectangle has the black one on the left, and then this one down here has the blue one on the left. So that's not going to work. Do not work. At least you could do it with two separate rectangles, two separate integrals. You could integrate from down here, from down here to up there, whereas this function is always on the right and the blue is always on the left. And then a separate integral from here up to there with, again, the green's on the right and this time the black's on the left. But that'd be a pain. We don't want to do that. So horizontal rectangles are not going to work easily because the horizontal rectangles have a different function on the left, the blue or the black, depending on where you're at. Whereas the vertical rectangles, they always have the black function on the top and the blue function on the bottom, no matter where you're at throughout the whole region. So vertical rectangles are going to work better because they always have the black on the top, the blue on the bottom. There's no switching. So that's what it's saying. Draw. So get your 2D thing. You can just look at this. It's really quick during an exam. Just graph it on the 2D grapher, the Desmos 2D grapher. Then just look. Vertical rectangles. Oh, yeah. Same, same, same. Always the same. Whereas the horizontal, oh, no, that's different. Different on the left from there to there. No, not horizontal. Vertical only. And then I gave you a table on what that means. If you go back to this table, wait, if I can find the table. Where is the table? There's the table. So basically, we have what? Only vertical, right? Only vertical or allowed. And we're rotating about x equals 5. X equals 5. No, I'm sorry. We're not rotating about x equals 5. That was a mistake. X equals 5 is part of the boundary. We're rotating about the x-axis. That's what I should say. So we're rotating about the x-axis and right, yeah, right here, rotate about the x-axis and vertical rectangles. Well, you can see on this table, if you have only vertical rectangles, x-axis, discs and washers are all that's going to work. And that's what I wrote right here. Only vertical, rotate x-axis, disc washers. So that's how we know it's a disc washer. So I go, okay, discs and washers. So then I go to the disc, and you can see it on there's the shell method. See, if you have shell method, and we're saying only, and you have rotate about the x-axis, right? X-axis. You need horizontal x-axis shell. Our horizontal are not working, only the vertical. So again, I'm just verifying. Come back up here. Disc washer, x-axis. You need vertical, and that's exactly what we have, vertical. So there's the formula we're going to use right there. vertical rectangles work, for dishwasher about the x-axis. So our integral then will be, what does it say? Pi left to right, just grabbing this right here, capital R squared minus little r squared dr. So that's going to be integral from left to right. So now we go back and look at our function. So left, right, you can see the left side here is at 2. The right side, this is 5 right here. The right side, that's our region from 2 to 5. And we're going to have um, the 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 radius goes, I can put it on here for you if it's helpful. The capital R is going to go all the way up to there. That's our capital R. And the little r is only going to go up to that function. So the capital R goes up to the black function, which is the y equals 3x plus 10, the one that's on the top there. And the little r only goes to the little function, the blue one over here, minus 3x plus 22. So there's the little r, the big R, just like the picture. So the 3x plus 10 is on the top, minus 3x plus 22 is on the bottom. So we go back and go, okay, right to here. And we're going to go from, so the capital R, see the picture here, the capital R is all the way. So the capital R was was the 3x plus 10 squared minus the little r, it's just this part right here. And that was the other one, minus 3x plus 22 squared. And don't forget the pi. And we're going to go from the left to the right. What was that? Back to the picture. Oh yeah, 2 to 5. From 2 to 5. So, and then of course we have the d um, x. Yeah, this one's dx. Should say x, right? Dx right there. So there we go. So let's go make, oh, and you got to put brackets around this. So, you know, the pi multiplies the whole thing, right? Okay, 2 to 5. Was that the answer they gave? I'm getting lost in my work here. Yeah, 2 to 5, 3x plus 10 squared, minus 50, there it is, and parentheses around the whole thing with the pi in the front. There it is. And so that's how we do it.